single day, in kitchens all across the world, people reach for a bottle of sunflower oil without ever stopping to think about the journey it actually took to get there. What most people picture is probably something simple: seeds get squeezed, oil comes out, done. But the reality is a jaw-dropping industrial process involving massive combine harvesters, seed cracking machines running at unbelievable speeds, chemical solvent extraction, high-temperature vacuum distillation, and robotic quality control systems that inspect every single bottle before it ever reaches a store shelf. Sunflower oil is not just some small niche product either. We are talking about a global industry that produces more than 20 million tons of oil every single year, making it one of the most consumed vegetable oils on the entire planet. So how exactly does a field of bright yellow flowers turn into the clear golden liquid sitting in your pantry? Today we are going to walk through the entire process from start to finish, from the moment seeds are planted in the ground, all the way to the moment a sealed, labeled bottle rolls off the line ready for shipping. Trust me, once you see everything that goes into this process, you will never look at a bottle of cooking oil the same way again. Welcome back to the channel, Mass Production Process, the place where we break down exactly how the everyday products you use are actually made on a massive industrial scale. If you enjoy seeing the hidden machinery and engineering behind the products in your own kitchen, do me a favor and hit that like button. And if you have not subscribed yet, go ahead and do that now, because we have got a lot more deep dives into industrial manufacturing coming your way. All right, let's break this whole process down step by step. Stage 1, growing and harvesting the sunflowers. Everything starts long before any machinery is involved, out in wide open agricultural fields, where farmers plant sunflower seeds specifically bred for oil production. Now here's something a lot of people do not realize. The seeds themselves are naturally packed with oil, containing anywhere from roughly 35% all the way up to 50% oil content by weight, depending on the specific variety and growing conditions. That is an enormous amount of oil concentrated inside a tiny seed, and it is exactly why sunflowers became such a valuable crop for oil production in the first place. After the seeds go into the ground, it takes somewhere between 50 and 70 days before the fields transform into that iconic sight most of us picture when we think of sunflowers. Dense clusters of hundreds of miniature individual flowers, all grouped together tightly to form what looks like a single giant flower head. What most people do not realize is that a sunflower head is not actually one flower at all. It is a massive collection of hundreds of tiny flowers packed into a spiral pattern. And each one of those tiny flowers has the potential to develop into a single seed if pollination is successful. This is nature's way of maximizing seed production within a compact space. And it is a big part of why sunflower fields are such efficient oil-producing crops. The growing process does not stop there, though. The plants need roughly 150 days total from the moment of planting before they are actually ready for harvest. As that timeline approaches, something interesting happens to the plant. The once bright, vibrant, sun-tracking flower heads begin to naturally dry out and droop downward. This drooping is not a sign of a dying or unhealthy plant. It is actually a critical and necessary part of the maturation process. As the flower head dries and lowers, the moisture content inside the seeds drops significantly, which is essential for both storage stability and for making the seeds ready for mechanical processing. Wet seeds are much harder to process efficiently and are far more prone to spoilage, so this natural drying phase is basically nature doing quality control before the machines ever get involved. Once the fields have reached that mature, dried-out stage, it is time to bring in the heavy machinery. Massive combine harvesters roll through the fields, fitted with specialized cutting platforms specifically designed to target and slice only the seed-bearing flower heads, rather than harvesting the entire plant stalk. This precision matters a lot because it keeps the harvesting process efficient and reduces unnecessary plant material clogging up the machinery. Once the flower heads are cut and pulled into the combine, internal rotors get to work separating the actual seeds from all the surrounding plant fiber and debris. From there, the seeds pass through an initial cleaning stage right inside the combine itself, using a combination of air-blowing systems and vibrating sieves to remove lighter debris like leaves, stems, and chaff. Once cleaned to this initial standard, the seeds get dumped directly into waiting trucks, and these are not small trucks either. We are talking about vehicles capable of hauling up to 22 tons of seeds in a single load, ready to be transported straight to the processing facility. Have you ever thought about how many individual seeds go into just one single bottle of sunflower oil sitting on a grocery store shelf? Drop your guess down in the comments, because honestly, the real number might surprise you once you see how much oil actually comes out of each seed. Stage 2, arriving at the factory and getting whole. Once those loaded trucks arrive at the industrial processing facility, the seeds go through an intake process that is honestly staggering in scale. Every truckload gets weighed to track exactly how much raw material is entering the facility. And from there, the seeds are run through a combination of vibrating screens and air separation systems. What is truly impressive here is the sheer processing speed. These systems are capable of handling an astonishing 25,000 tons of seeds per hour, clearing away any remaining dirt, small stones, leftover leaves, or other unwanted debris that made it through the initial field clean. This intake stage acts as a critical quality checkpoint before the seeds are allowed to move deeper into the actual oil extraction process. Once the seeds have passed through that intense cleaning stage, they move into what is known as the hulling process, sometimes called dehulling. This step is absolutely critical to the entire operation because the sunflower seed is not made up entirely of oil-rich material. It actually consists of two distinct parts, the oil-rich inner kernel and the tough, fibrous outer hull surrounding it. That outer hull contains very little oil and would just get in the way if it stayed attached. So mechanical impact hullers are used to crack open each and every seed, physically separating the kernels from those fibrous shells. Once the seeds have been cracked open, powerful air streams are used to lift away the lighter shell material, effectively separating it from the heavier kernels through a difference in weight and air resistance. But here is where this process gets particularly clever. From a sustainability standpoint, those separated shells are not simply thrown away as waste. Instead, they get diverted and burned directly on site as clean biomass energy, actually helping to power parts of the factory's own operation. This creates a surprisingly efficient closed-loop system where a byproduct that might otherwise be considered waste actually becomes a valuable energy source, reducing the facility's reliance on external power and cutting down on unnecessary waste at the same time. With the hulls removed, the naked oil-rich kernels move forward into the next critical stage, lamination and heating. Heavy laminating rollers apply intense pressure to physically crush the plant cells within each kernel, essentially breaking down the cellular structure that is normally holding the oil locked inside. This crushed mash then goes through a gentle heating process. And the reason for that heating step comes down to basic physics. Heat reduces the oil's viscosity, essentially making it thinner and more fluid. This thinner consistency makes it dramatically easier for the oil to actually flow and release from the plant material during the extraction stages that come next, all while being carefully controlled to avoid damaging the oil's natural quality. Stage 3, extracting the actual oil. Now we finally arrive at the stage most people probably picture when they think about oil production. And this happens in two distinct phases working together. The first phase is mechanical pressing. The warm, crushed mash that came out of the lamination process gets fed into continuous screw presses, industrial machines that apply an enormous amount of mechanical pressure to physically squeeze the oil out. As this intense pressure builds, crude oil gets forced out through carefully engineered slits built into the press itself, leaving behind a compressed solid byproduct commonly referred to as press cake, or sometimes called torta in the industry. This press cake is not oil-rich anymore in the same way the original kernel was, but it is not entirely oil-free either, which brings us to the second extraction phase. Because mechanical pressing alone cannot squeeze out every last drop. To capture this remaining oil and avoid wasting it, the solid press cake undergoes a chemical solvent extraction process, most commonly using a solvent called hexane. This solvent is specifically effective at dissolving the remaining trapped oil out of the fibrous plant material, essentially pulling out every last usable drop that the mechanical press could not physically squeeze free. Once the solvent has done its job and successfully extracted that residual oil, the resulting mixture gets heated in a controlled process, specifically designed to evaporate the hexane back out. That evaporated hexane is then carefully captured and reclaimed so it can be reused again. Stage 5. Automated packaging and getting the oil to store shelves. With the oil now fully refined, purified, and stabilized, the final major phase of this entire operation is packaging, almost entirely automated. Before any oil ever touches a bottle, those plastic bottles need to be thoroughly prepared first. Empty bottles pass through equipment that blows them clean using carefully filtered air to eliminate any dust or potential contamination. This might seem like a minor detail, but at an industrial scale producing thousands upon thousands of bottles, even small contamination issues could create massive quality control problems if left unaddressed. It is still filled with all sorts of solid microparticles, natural compounds, and impurities that need to be carefully removed before before the oil can be considered safe, stable, and pleasant for actual cooking use. This refining stage is broken down into several distinct steps, each one targeting a specific type of impurity or unwanted characteristic within the oil. The first refining step is called degumming. This process is specifically focused on removing natural phospholipids from the oil, more commonly referred to as gums. These gum compounds occur naturally within the seed oil, but if left in the final product, they can cause the oil to become cloudy, unstable, or prone to breaking down over time, so removing them is essential. This is typically accomplished by introducing water or steam into the crude oil. The neutralization process is specifically designed to eliminate these free fatty acids, bringing the oil's acidity down to an appropriate, stable level suitable for consumer use. Next comes the bleaching stage. The neutralization process is specifically designed to eliminate these free fatty acids, bringing the oil's acidity down to an appropriate, stable level suitable for consumer use. Next comes the bleaching stage. And despite what the name might suggest, this has nothing to do with harsh household bleach. Instead, the oil is passed through specialized filtering earths, natural clay-based materials, that are highly effective at absorbing unwanted pigments and remaining contaminants from the oil. This step is what gives the finished sunflower oil that clear, appealing golden color that consumers expect to see, while simultaneously pulling out any lingering impurities that made it through the earlier refining steps. Finally, the oil undergoes a process called deodorization. Even after all the previous purification stages, crude sunflower oil naturally contains certain compounds that carry strong natural odors and flavors. To eliminate these unwanted characteristics, the oil undergoes high-temperature vacuum steam distillation that effectively strips out those strong smells and flavors, leaving behind a clean, neutral tasting and neutral smelling oil. This is exactly why store-bought sunflower oil generally has such a mild, versatile flavor profile that works well across countless different cooking applications, without imparting any overpowering taste of its own. Which part of this entire process surprised you the most so far? The fact that they burn the seed hulls for energy, or the fact that chemical solvents are actually used to pull out that last bit of residual oil? Let me know what you think down in the comments, because I personally find the solvent extraction stage to be one of the most underrated parts of this whole operation. Stage 5, automated packaging and getting the oil to store shelves. With the oil now fully refined, purified, and stabilized, the final major phase of this entire operation is packaging, almost entirely automated. Before any oil ever touches a bottle, those plastic bottles need to be thoroughly prepared first. Empty bottles pass through equipment that blows them clean using carefully filtered air to eliminate any dust or potential contamination. This might seem like a minor detail, but at an industrial scale producing thousands upon thousands of bottles, even small contamination issues could create massive quality control problems if left unaddressed. Once the bottles have been properly cleaned and prepared, the actual filling process begins. The fully refined oil travels through a completely closed piping system, meaning it never gets exposed to open air as it makes its way toward high-speed automatic filling machines. These filling systems are equipped with high-precision sensors specifically calibrated to fill each and every bottle to an exact, consistent level, ensuring uniformity across every single unit that comes off the line. The moment a bottle is properly filled, it moves immediately into a capping station where it gets sealed right away. This immediate capping step is far more important than it might initially seem for preventing oxidation. Locking out oxygen exposure as quickly as possible is absolutely critical for preventing oxidation within the oil, a chemical process that can degrade oil quality and shorten its overall shelf life if not properly controlled. From there, the sealed bottles continue moving down automated production lines where labeling equipment applies all the necessary information consumers expect to see, including lot tracking codes for quality control. Alongside the labeling process, robotic inspection systems carefully verify multiple quality checkpoints on every single bottle, confirming that seals are properly secured and that fill heights meet the required consistency standards. Any bottles that fail to meet these strict quality standards get automatically flagged and removed from the production line before they ever have a chance to reach a store shelf. Once every bottle has successfully passed through this rigorous automated inspection process, the finished products get boxed together, carefully palletized for efficient stacking and transport, ready for shipment. From this point forward, those bottles are ready to begin their final journey outward into the global supply chain, eventually landing on store shelves where consumers will pick them up, without ever fully realizing just how much complex engineering, chemistry, and precision manufacturing went into producing that simple bottle of cooking oil sitting in their shopping cart, putting the entire journey into perspective. When you really step back and look at everything involved in this process, it becomes clear just how remarkable modern industrial food production actually is. What starts as a simple seed planted into open farmland eventually passes through massive combine harvesters, industrial cleaning systems, mechanical hulling equipment, high-pressure screw presses, and chemical solvent extraction, multiple stages of chemical refining, and fully automated robotic packaging lines, all before that bottle ever makes it into your kitchen cabinet. Every single stage of this process exists for a specific reason, whether that is maximizing oil yield, ensuring product safety, extending shelf life, or maintaining consistent quality across millions of bottles produced every single year. It is a genuinely fascinating example of how far industrial engineering has come, transforming an agricultural product into a stable, mass-produced good available at a scale that would have seemed impossible generations ago. Understanding a process like this really does change the way you look at something as ordinary as a bottle of cooking oil sitting on a store shelf. What seems simple is actually the end result of incredibly sophisticated agriculture, engineering, and chemistry, all working together in perfect sequence to deliver a consistent, reliable product to consumers around the entire world, day after day, year after year. If you enjoyed getting this behind the scenes, look at how sunflower oil is actually mass-produced. Make sure you are subscribed to Mass Production Process so you never miss the next deep dive. Thanks for watching, and we will see you in the next one.